Hello, so today we're looking at P9 and P14 because they're closely related. P9, describe how light, temperature and available moisture, oxygen, carbon dioxide ratios, wind and biotic factors affect plant growth, development and production. Explain how farmers can manage plant production systems to overcome environmental constraints. So they're very, very closely related. Just going to move me back up there. Okay, so the very first one is light. So plants use light for photosynthesis. We've got a little graph down the end here, down the bottom, and we can see that with this curve, that it flattens off, okay? Basically, it gets to a point where photosynthesis doesn't increase when we increase light that's available. Okay, so the curve flattens off. Plants reflect green light. They have some wavelengths that they use, and we can see that in this diagram here. And we can see output from photosynthesis with the different wavelengths here. So plants are affected by the intensity of light. Light inside a house can have lower intensity than outside. Many plants have a light requirement for flowering. This mechanism is called photoperiodism, which is basically and we're looking at the length of dark time. So plants can be divided then into 3 different categories. So short day plants, which have conditions less than 8.5 hours, long day plants, flowering conditions of greater than 11 hours. Then we have day neutral plants. So they're non-specific, okay? Right, next page. Turn my phone off. So management of light. This is one of those ones. We can, in intensive production in a glass house, like our diagram here, we can have artificial light. For the most part though, we can't control this. We can, however, control removal of trees and understories and stuff like that to stop shading. But another thing that we can do is looking at specific plants for a specific climate. So C4 plants are better adapted to more intense, longer periods of light than C3 plants. So most of the plants that we grow in this area are C3 plants. So they're adapted to lower light levels and shorter periods of light, but also less light intensity. So if you go to north, like sugarcane, I'm pretty sure is a C4 plant. There's grazing plants that are all C4 as well. Now the C just refers to the carbon, amount of carbon that's put out. Constraint. So we've got air temperature, has an effect on plant growth and production. For every species, there's a maximum and then a minimum, and then there's an optimum, okay? So an optimum temperature just means that it grows best at. So we've got our examples here, lucerne, that's a lucerne flower, and its optimum temperature is 30 degrees. Then we have wheat. This is a harvested wheat, and its optimum is 25. Okay, so it's better adapted to cooler temperatures than lucerne, though lucerne's still fine in these areas. Management of air temperature. So you need to plant for the optimum time of year. You can, so in glass houses, you can have sensors. If you need to cool the glass house down, that you would open up windows on a sensor, increase fans and all that kind of thing. Plastic covers placed around plants, so we call them cloches. On small scales, you might see them over strawberries and things like that. Shade cloths are used to decrease heat and light intensity. Constraint 3, soil moisture. So most crops rely on natural rainfall to supply all the moisture during the growing season. So in our broadacre, that's especially the case. Only a small amount of our broadacre crops are irrigated. So farmers are concerned with total rainfall, seasonality, so when it's falling, and reliability. Reliability just means, is it going to happen every year? So Bathurst is way more reliable than, say, around Walgett. So around Walgett area, they would budget on, like, you get a crop 1 in every 5 years. Okay, then we have the effectiveness. So if you have a really intense rainfall event, the water runs off the surface rather than soaking in. Okay, we know that soaking in is like called deep percolation. We want the water to go into our soil profile rather than just running off the top. So waterlogging, I'm not sure if we've spoken about waterlogging, but basically that is when you've got too much water and the plants can't function normally. So it reduces the crop yield growth, it depresses tillering, so you have less runners going up from our plant, and it reduces the nodule formation in legumes. Okay, you'll see a waterlogged crop because it looks yellow. So basically what happens is that the nitrogen can't be taken up by the plant and it turns yellow. Limited water reduces the photosynthetic, let me say that again, the photosynthetic rate, because it's an input. So water is needed for photosynthesis. Management of soil moisture. We've got a diagram here of our, why isn't that drawing? We've got a diagram of our soil moisture probe. So basically we can use these soil moisture probes to measure where the water is in the profile, particularly handy for budgeting on what your crop yields might be and all that kind of thing. You need to know whether it's worthwhile applying an input like nitrogen. If there's not enough soil moisture to get your crop through and you're in a marginal area, it might be worthwhile adding any extra nitrogen to those crops. We use it in irrigation to make sure that we're not losing water down through the profile, and making sure that we're getting enough into the root zones. So fallowing, so I'm not sure why my highlighter's not working. So fallowing the ground is basically just making sure that the paddock is weed free for a long period. So any of the moisture that falls in that paddock goes into the soil where it can be then stored. Hopefully we've got lots of organic matter in that soil that can store that moisture for you. All that water then is then used during the growing season of the plant. Okay, so irrigation is just supplying the crop with adequate water. Most properties don't have any access to irrigation at all. So more intensive cropping, what is expensive? So you need to have a really good profitable crop to be able to justify you watering it. So irrigation is successful in modifying the microclimate and increasing net assimilation rate. So net assimilation rate is just the increase in vegetable matter. Okay, so how much photosynthesis and then is being turned into vegetable matter. So how much vegetation that the plant's producing. So this bottom one here, increasing organic matter content of the soil increases the ability of the soil to store water. We've spoken about that a heap. Okay, so constraint 4, oxygen and carbon dioxide ratios. So carbon dioxide concentration in the atmosphere is about 0.03%. The level of carbon dioxide, I can't read that, concentration in the canopy of a rapidly growing crop can be so reduced by absorption of the crop that it becomes a limiting factor. I'm not sure that that's such a big deal in broadacre, normal sort of cropping environments. It may, like if it was really still conditions, maybe, big maybe. In greenhouses, I know it's definitely an issue. So a couple of things that they can do for management is that they can have carbon dioxide generators. So this diagram here, this is a carbon dioxide generator. So basically it's pumping carbon dioxide into the greenhouse. They'll have ventilation, so you want that airflow mixing up that carbon dioxide so that the plants have got adequate usage. Really interesting picture to the side of it here. We've got our greenhouse level low and our greenhouse level high. We can see with the higher parts per million, okay, they've got a lot more vegetable matter. So this is about where we're at now. So in normal atmospheric conditions, this is way higher. So global warming is a good thing? Probably not. Okay, what have we got here? So constraint number 5, we've got wind. So wind can uproot trees, it can push over crops, make them unharvestable, okay? We call when say if wheat gets blown over and the plants literally fall on their sides, we call that lodging, okay? Kills the plant, you're often contaminating sometimes you can harvest it, but you're contaminating your wheat with soil, and then you get fungal growths and all that kind of thing. It's not ideal. Another issue is sandblasting. So particularly in sandy soils and on the edge of crops and fields, you will get sandblasting. So if it's really windy and you've got sand being picked up by the wind, or sand or dirt particles, and it will burn off all the green layer of the plant. So, and it mechanically, physically destroys the plant. So we can manage this by having some windbreaks, okay? So you'll see in our diagram there, we've got different sizes of trees so that there's a full canopy that's breaking up the wind, forcing it up and over, okay? And we need to have them spaced throughout the farm. Biotic factors, constraint number 6. So biotic just means living. Bio-living. And we're talking about pests and diseases here. So eating or damaging leaves, sucking the juice out of the plant, i.e. aphids do that, damaging the roots or stems, so take-all, which is a fungi in wheat. I've got another example in there, cutworms. So cutworms will go and basically just eat through the roots, and they'll cut the stem off, and so the plant dies. We get the root borers in our grasses, our lawns, in our houses when we have water. Similar issue to cutworms. And production can be reduced by attacking the harvested products. So interestingly, so weevils is a little animal that does that. You might have seen them in your pantries, in your flour. We've actually got some in the grain that I'm feeding the chooks at the moment. So that can be an issue for stored grains. Now, so our management of biotic factors, we have, so you're doing this assignment now, so IPM. So physical, chemical, biological, and cultural controls. Right, we've got this table here now. I need to move my head. All right, there we go. So we've got this table that summarizes all of that information that we've just put up, okay? So have a good look, it is all there. Now, I hope all is going well. If you've got any questions, please do not hesitate to send me an email or ask a question on the Google Classroom. No one's asked any questions on Google Classroom yet, which is a little bit disappointing. So ask some questions, you'll be helping your classmates out, and you'll be giving something for me to do. So thanks heaps for that. I hope all is going well. See ya.